Okay, let's work on this one. I am looking for a third degree polynomial where I have roots at -1 and -3, and the multiplicities of both those roots are 1 and 2 respectively. So I'm looking for that -1 to occur once and that -3 to occur twice. So let's write down what we're looking for. Let's give it a name, f of x. It's a third degree polynomial, right? So I'm looking for ax cubed plus bx squared plus cx plus d. I don't know what the a, b, c, or d is, but that's a third degree polynomial, right? Every third degree polynomial is going to look something like that. So let's use what we know. Instead of writing it in this expanded form, let's choose to write it in factored form because I know the factors, because I know the roots, right? I have a root at x is equal to -1. So I know that x plus 1 is a factor of this polynomial because if x is equal to -1 there, that factor then becomes 0. For the exact same reason, I know that -3 is a root, making x plus 3 a factor. Now let's make sure that we have the right multiplicities. So this factor occurs once, and it was only supposed to occur once. The x plus 3 factor needs to occur twice. So let's put a little 2 on that x plus 3. Right? If we count our x's, we should be done. I've got 2x's from there and another x from there. So that gives me 3x's. That gives me that third degree polynomial. But I have an extra condition. I need to make sure that my y-intercept is equal to 2. So what can I do to this function to make sure that I can have the right y-intercept? I can multiply it by some unknown number, right? Because if I multiply a function by a number, it doesn't change my zeros, right? This -1 is still going to give me a 0. -3 is still going to give me a 0. But I can vertically dilate that function using this factor in making sure that I get the right y-intercept. So let's see what we have so far. I need the y-intercept to be 2. So I need this function at 0 to give me a 2. Well, right now I've got e times 0 plus 1, 0 plus 3 squared. Right, that's my function at 0. That's my going to give me the y-intercept, and I need that y-intercept to be 2. So let's simplify. I've got 2 is equal to e times 1, right? That factor is just a 1, times 3 squared, which can be further simplified to 9e. So this is going to tell me if I divide both sides by 9, that e is equal to 2/9. So the function that I'm looking for, as it stands right now, was e times x plus 1 times x plus 3 squared. And because of my y-intercept condition, I know that e is equal to 2/9. All right. So technically we're done. This is a third degree polynomial with the right roots and with the right intercept. But let's just go ahead and expand this to get it back up into standard form. The ax cubed plus bx plus c plus, or sorry, ax cubed plus bx squared plus cx plus d. So I'm going to leave this 2/9 there. I'm also going to leave that x plus 1 there, but I can tell myself what x plus 3 squared is. That'll be x squared plus 6x plus 9. All right. Now let's figure out what x plus 1 times this quadratic is. So if I send the x through, I'm going to get x cubed plus 6x squared plus 9x. Now, if I send this 1 through, I'm going to get plus x squared plus 6x plus 9. All right. Now let's finally deal with this 2/9. In fact, before we deal with that, let's keep it out there. Let's combine anything. I've got x cubed right there. I've got plus 6x squared plus another x squared gives me plus 7x squared. I've got plus 9x plus 6x gives me plus 15x. And then I have that plus 9 at the very end. All right. So sending this 2/9 through, I get 2/9 x cubed plus 14/9 x squared plus 30/9 x plus 18/9. And we can go ahead and simplify this just a little bit. 2/9 x cubed is fine the way it is. 14 and 9 have nothing in common. But that 30 over 9, I can write as, I can take a 3 out of both of those and I get a 10 over 3. And then that 18 over 9, I can take a 9 out of both of those and I just get a 2 over a 1 or a 2. So we know that our zeros are correct because this cubic function, this degree 3 polynomial, came from this cubic that has the factors that we want, or rather, this cubic that has the factors that we want. And I also know that that 2/9 right there gave me the right y-intercept because I can evaluate this function when x is equal to 0. And all of these terms are going to be 0, which will leave me with just that 2. So I do have the right y-intercept. All right, so this is the cubic function that we're looking for. All right. Hope you found this helpful.